that we might be asking in this example. Paper. The exam paper from IIT Madras is going to be only conceptual oriented. As we are teaching the concept, is trying to ask. Okay. Does that clarify the question relating to the exam? Or do you have any other questions relating to the exam? Okay. So voice is speaking. So what can I do? I think is that happening for others also? I'm doing my best. So this breaking, there's no problem with the internet connection. Is the voice coming clearly for others? Please respond. No. Is it no or yes? Is the voice breaking for Jntuk? K48 also. He seems to have connection problem currently today. I'm seeing him. Background sir. Okay. And L3 is the voice. Okay. So audio video is good is what somebody is saying. Fine. So let me go back. Now I think I've almost spent 20 minutes, not going much as far as today's lecture is concerned. Okay. Let me give you a hash of what I've been doing so far. Okay. I'm trying to teach you how to write. I'll also give you some idea on where I'm reaching with this material is how to write distributed programs. I've taken Java as a case, okay, and I start from simple client server program. How do we write client server program Java? Okay, I've written a small client. I've written a small server. Server sends a string. The client receives the string. The server receives the string. Just prints the string. This a client has sent. We have written this program. When we wrote this program, we understood how you can open sockets in those files. So sockets are I/O devices kind of thing as far as the program is concerned. So we have actually done that as part of the first example. We actually showed how such programs can get out if there are multiple clients trying to work with a single server. Okay. Then we actually went on to create a multi-threaded program, and we showed why multi-threaded program work in such scenario as the whole number of clients that are accessing the server. Okay. So we tried showing you how to write a threaded program, first threaded program. Okay. We created a thread for each client request and how each server thread can process the client request independently in terms of reading whatever is client is sending and printing whatever is the client sending. Okay. Since it's a multi-threaded program, we also showed how multiple clients simultaneously sending will have a better response in the case of a multiple program versus a single thread running, single server thread running. Okay. That is what we have done so far as this goes out. Is everybody with me on this? I'm hoping, since I'm not seeing any thing happening on the chat, I'm assuming that everybody will receive me now completely. Okay. Now let me go forward. Okay. Now it is what I'm going to show you about how I want to go forward as far as this class is concerned, this course is concerned is I will repeat that exercise where a single thread, threaded one, how it is a better program. I'll start with that and we'll try to go and show you that. Okay. Next, it is possible to modify that program further. assign a free thread each time a request comes. You can assign the thread to the one free thread in the pool. Okay. For example, a priori you can create 5 threads as a client thread. Okay. And when the client request finishes, you are actually destroying that thread. Whereas in the and hence the new thread overhead can be multiple times and multiple sets. Okay. Screen is not visible. Screen is not visible. And not like am I visible? Okay. Okay. So probably I should not press screen. Okay. I should go ahead and start. Time 3 o'clock because I've not probably that's why I'm create a new format where I might actually go a little longer discussion in one class. Okay. Right? Yeah. Okay. So so the idea is, if you have a multi-threaded program, the threads are priorly created and the free threads are assigned to the clients. Then you have a pool of workers. These are like threads are like workers. So the pool of workers as party sending the request are actually finding a free thread in the pool and assigning the work to be expected to write programs that work when millions of clients simultaneously can be accessed to a server. And that's very important. That's why the scalability aspect of distributed program is the most important thing. Okay? Right? So that's what we are trying to teach you here. We are not just trying to teach you how to write this small distributed program. We are also trying to teach you how you will design your distributed program so that it is optimized from a scalability point of view. Okay? As more and more I'm actually not showing the program yet. Okay, please understand. I'm only talking first place. I'm only creating a context for you. Please listen to me there. Then we will go to the program. Okay, I'll go to the program. Okay. Given this, what I'm going to do next is I will move this server to the cloud. Okay. Whatever server we are seeing here, in my next lecture or so, I'm going to move this program area and the department. Going to be different from writing programs in the cloud environment. So I'm doing that as I move forward. Okay. I move further, I'm going to tell you if you have 10,000 servers on which you are programming, this mechanism of writing distributed programs is certainly not going to work. Because if you have a data center of 10,000 servers, you can't write programs the way I'm writing now. Okay? It will be extremely difficult to do that. That's where we start introducing the concept of object-reduced programming or programming in the cloud. Okay. program. We're going to show you that. Okay, right? So that's what we going to do. Now let us go for. Okay, I'm going to take a little more time as I inform you. Go a little slower. I spend a little more time with you people. No. Is there any question from anybody up till now? Whatever I've discussed, I'm just trying to set the context clear for you. Okay. Okay. There is a question from Vijayanagaram campus. Okay. How Facebook can handle 100 requests. Okay. Right. Now the question is, there is not just one server there. As we go into some of the later parts of the design, this is also like Yahoo email or Google email services. There are 100 million users at any given point of time, and as the user is logging in from multiple places, you have to make your mail boxes. Okay, boxes available, and one of the other interesting thing about the other day we had the vice president of PayPal visiting us. Most of you will be knowing about PayPal. PayPal is basically a payment gateway. Okay? A second, if the machines there, they use about a 10,000 plus node cluster for doing their back-end operations. The merchants paying, it's a payment. So again, millions of requests will be happening in a particular day, right? So a 1 second down time of the server costs them about few thousand. It translates to about in terms of Yahoo or one time down downside, which are of moving the or designing the distributed programs system. Okay. I have one question for Vijay. Okay. They are online. I'm actually have one question for network file system. Which have network file system. The minute that's actually file sharing system. You put your file in the server, and you can actually share these files across tens and these lines. The minute the number of jobs become about 1,000, no works. Now file systems like Hadoop file system, okay, Google file system, on top of it databases, which will try to cater to terabytes of data for millions of users at a given point of time, and the singular decomposition of that matrix, okay, on your laptop or something. You won't be able to, okay? This is possible to be done on your machine. But then, what we are going to show you, the kind of technology that will our client-server program. But understanding of these programs, how we write traditional client-server programs before we reach there, where this program are automatically generated by a compiler kind of a thing, okay, which can be used, and that's what we're going to teach you as we move forward. Okay, that sort of give you understand whatever I teach you. Okay, that's the reason why starting with a program and I'm actually changing, okay, these programs incrementally, slow by slow, so that all the conceptual base is completely built for you, in terms of lot of that. Other than I think just program and then go more abstract for you. It may not lead you to a complete understanding. That's the reason why I'm going incrementally, first starting with a very small program, how it returns, and then slowly changing to bring in all the complexity that exists in writing those big programs. Okay, that's how we are going in this particular course. Right now, for the rest of the class today, I will again show you what I have done last. Written a small client-server program. I will show you that client-server program. I modified it. I show why it won't work if there are multiple clients operating with that particular server. And modification and finally, I will show you the modification I have done to actually Moocs. Okay, that is the end. No, we have repeating some of, so that some of you who would have been in my desktop now. I start sharing my desktop, and then you should be able to program now. Okay, yeah. So you should be seeing the desktop now. Okay. This is the program that we are showing you, and in fact we have shown you the client program. This is the client program that we have written. Okay.
చెప్పండి సార్.
And the socket port number is 81.
వస్తుంది.
Once the socket is created,
అదే కమాండ్ లైన్ అదే టెర్మినల్ ఓపెన్ చేశారు సార్.
console.
వస్తుంది, కాకపోతే కొంచెం బ్రేక్స్ వస్తాయి అంతే.
And we are writing this message. As you can see,
డెస్క్టాప్ కనిపిస్తుంది. కనిపిస్తుంది.
out.write send message. This is the point where we are writing this message onto the socket and sending the program to the server side. Okay, the server is running on 10.6.9.81 and the port number is 8127. That's where this server, this client program is trying to send a message to the server side. Okay, this program we have seen previously. We are actually looking at, we are not doing modification on the server side. I can use that for writing back to the client, and client can read now from that socket and then get whatever is the server writing. I can create two new threads on the client side, one for sending and one for receiving. I can make that modification into the client side. I'm not doing this. I'm giving this program to you. You can take these programs and make that modification that client can, while sending it, uses one thread, while receiving uses and sort of take it from can do whatever modifications you want to do for this programs. First modification you can attempt to do is on the client side, you can write two threads. One thread for sending and one thread for receiving. Okay? The same thread S can be used for result. You can see the get outputs of the socket. So we are going to call socket get input C to get an input handle to this socket. Okay? Then you can read whatever the server sending back here. What modification I do is change this program to this is where my server program is running. So this is the I think we take several more versions of this book. Okay. Okay. Yeah. Okay. You can see simply we all different versions. Okay. As I'm see, I've actually created. So you see that I've commented out the change. Yes, because I wanted it back to my original version. I've actually destroyed it. Okay. As you can see in this program, I'm opening the while loop and true loop. I'm opening a server socket. Yes, here. SS accept is returning a socket. This is the client socket that I have now. Okay. Now I can read or write on this client socket. Okay. The first program that we wrote is a program where whole loop here is one loop. We accept and do all the work. Okay. Do all the work with the client request. Then go back to the so the server accepting the request from the client also does the full work here. Okay. I'm showing last time, this thing of trying to put, for example, in this case, if you put the thread sleep, okay, long time you make this thread sleep. Okay. What happens is this new connections from the other clients should get blocked because this while loop should take a very long time to execute. Okay, and hence this code here, the while loop code should block other clients from getting response from the server. Okay, we were telling in the last class. Okay, as you can see, we actually have only one shell here. I will try to create another shell and start the two programs for us to see. Example, Okay. Think this will sort of now be here. Okay. Let's see. I've just been here now. Okay. So as I go here, I think it will be nice finding okay. So the first client got accepted here. So the first client also got accepted here. Clients done for that. Okay. Now to run a second client now. The second client you can still not reach the s equals to ss dot accept. Okay. Ss dot accept. Okay. Right. Now let us see if I modify this. If I just remove that red sleep. Okay. Comment it out so that we are not actually now we do the okay, user dot Java. Okay. Now you do the Java on this new server dot server. Okay. Okay. Now the as we said earlier. Now try to send one more thing here. Okay. If get respond immediately because I removed now. Okay. So try to publish here saying that ground. Okay. Now it's all together. Okay. Here and start waiting a new connection cannot be accepted by because the while loop is not still finished. Okay. Now once the format is then I say now that there is a thread sleep introduced here, it means that the program is going to take long time here, then and it is not going to work anymore the same fashion. Okay. Now let us run this new server. Now let's go back. Run this client. Run this. The first one will come up. Okay. But then once you start the response, after this, the response will not be from the server itself. Now try to run new client here. Okay, this will be buffer. You just go off here. Okay, water. 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 Okay. Yeah. Okay. So this gets blocked now. So, as you can see, we actually did a rework on this, and we said that we can have a second version where we push all of this to the thread. Okay, so this is what we created as version of the program. Okay, just to sync up with you, seeing that. Just to sync up with all of you. I think, is there any questions so far? It's okay, right? Everything is going on fine. So, I'm actually now looking at I want some more water. Okay, so okay, so we are looking at the second, the actual what is happening in while has been pushed into the thread here, sub-thread. Okay. Now this server thread is having, as you can see, some thread here having constructor. The constructor and passing whatever socket that is accepted by the actual code of the while loop. The whole of the code that is happening in the while loop has been moved into this run method of the server thread. This is reading from the socket and then printing what the client says. All that code that we saw previously has been moved into this run method block. The actual server will not get blocked, okay, because it is only blocking the thread, not the actual server. Because the server listen to the next class. That is a modification that we did to this. The start, to make sure that you start a thread, to start the thread is actually stop the thread. And then it starts running. Okay. So the server thread has two methods, and then it is the same as the old thing. All that we did now is we just modify the earlier while loop that we had. I commented on. I want to comment. I'm actually modifying the old programs. So the whole server has just become this while loop. You access 1 second. This server that actually now to the is going to and it will accept up and it will go back into the while. So you're actually doing this like this stuff. And that's how you're actually server can still respond because every client request here is just started as a new. For example, once this code, once I've accepted this, start off it in red here. Okay. Right? So I'll come back quickly to assess we had actually introduced. I think there is a version 2.1. I'm going to share all these things with you. So you will get all these programs that I sent. I'm doing it here for stocks. Okay. Now as you can say thing except that here I would have new client request and pin this off into a new thread. Okay, so that will be sleeping, but it can still accept new connections from the client side. Okay, this is what we have done in the last class. Okay, let us look at this. So let us do this. Okay, I just seen while I now got into the while loop and I am accepting a connection. Okay. Now you go here and then I say Java this should have why this should be okay. This is already second okay. So it is already accepted. So once again the text click by one actually do not have to the right and right by making it multi-thread as you can see server response is suddenly true. Server is not get that, and again this is able to so as a final this thing, what I want to show you is, I'll take a few more minutes and I will try to then take questions. The final modification that we wanted to do for this program is something where you can say there are pre-created set of threads. Each time in this program, in the server program, I am creating a thread each time the client request is coming. Okay? Instead of doing this, what I want to do is I want to actually create a set of threads a priori, and then want to see if I can use, not collect, create the threads each time, but then use the threads as they are happening. Okay, that means I presuppose their threads, create n number of threads to start with, and I use one of the 3 threads as my incoming. Okay, I will use now what is called an executor service. There are multiple ways this can be done. Okay, now what I will show you is one framework for creating. This is the most popular framework for creating a set of threads, and then assigning one of the threads for the incoming client request. Okay. Now you can see here I have the Java. I need to actually use the concurrent package here, Java concurrent dot executor service. I need to import these 2 things. For using this framework, I am using a framework here, which is the most popular framework. There are other ways in which also I could have created a set of static set of threads, and I could have assigned one of the threads, okay, for an incoming client request. I could have done that. Okay. But what I am trying to do is now I am trying to use a framework which provides this support for me, and this is part of the Java util.concurrent.executor service. And this Java import both these things. Okay. The rest of the code here looks the same, except that what I will use now, I will use the executor service. As you can see here, I will just go to the new server here. From here it actually changes a bit. Okay. As you can see, I will now create a thread pool here using the executor use 6 thread pool. This method is part of the executors. Okay, the class, the object called executors. Now create an executor object, which are done here. Okay. The new thing I created the executor. Okay. Then I am actually creating a new fixed thread pool of size 5 here. That means 5 thread pool will be created here. Okay. Each of this is called the executor. As you can see here, each of this which is created is called the executor. So I have created an executor service, and I have created a thread pool of 5 thread pool I created. Now what I will do is, as I am accessing the incoming server pool, I have created a new thread, but then what I have done is, instead of saying now starting this, I am actually depositing this thread with the executor. So all that we are going to say is executor execute this thread. Okay, I create a new thread. This new thread is notional because when you want to execute this, the way it is going to happen is you pick one of the 3 things in the thread pool and gets assigned. Okay, so here I created. So I am saying here in this case, new fixed thread pool of size 5, and this is the place where I am executing the thread. Okay, this is what is the scene I have made now, and I will go a little deeper on this in the next class. Once this framework is available for me, all that I am going to do is now run this framework, which will sort of create a thread pool now. Each time, this is actually executing the same program. So this will now make the final change, saying that I have this new kind of a file pool together. Okay, that's a program that I finally created. Okay, now this shows how the thread pool can be created. A new thread pool can be created, which takes 5 threads, and then it is more than you will have problems. So it's actually you have to create a fixed number of threads, and then you will use the fixed number of threads for doing the work. Actually, if you compile this program, this will be much faster than the previous program, because creating the new threads for each client network and would be destroying that client thread as it is up. Okay, this is the final change that we have made into our program. This brings the first set of lectures to some conclusion. I'll go a little deeper on this for some more time in the next class. But then I will share all these programs with you. I'll send all these versions that are written, these programs to Murthy. Murthy will make them available. Now you can actually create multiple. On the client side, you can create 2 threads. On the server side also, you can create two threads. Please do this modification. As an expert, I know I can debug programs faster and make them work. But then, if we have to do the same thing, we will really realize how much effort has to go for a single program to make it work properly, correctly. Okay, right? But then that's an exercise that you should go into now and start writing these programs. Okay, right. I think with that I will stop today. I've taken a little extra time. Possibly I will take some questions. If anybody has a question, then I'll take those questions and come back if possible. Okay? Yes. So any questions? Okay. If there are no questions, yes, we're able to really see it. Okay, that's fine. So if there's anybody else who wants to be on the this thing, okay, I guess I have sort of done the part. So I'll come back. I think there's a question. Yes. Okay. Campus, whether we need to close. Whether we need to close what? Campus, how many live notes? Campus, whether we need to close. Okay. Campus, let's see. I don't know. Okay. So I think I will now